Bismillahirrahmanirrahim and Assalamu alaikum, dear students. As you all know that we already discussed about the members of the period 3, that what are the members of period 3 and their all related properties, including ionization energy, atomic radius, electronegativity, their physical structure, their intermolecular forces, and all other properties. Today we are going to focus on the chemical properties of period 3. What does the chemical properties mean? That how they react with different other compounds, elements, or molecules. Today we only focused on reaction with water, reaction with oxygen, and reaction with chlorine. You must know that whenever any element reacts with water, it forms hydroxide. When it reacts with oxygen, it forms oxides. Similarly, whenever it reacts with chlorine, it forms chlorides. One by one, we will discuss all the reactions, that how these different elements react with water, oxygen, and chlorides. First of all, we're going to discuss the reaction with water. First element that belongs to the group 1, that is sodium. It reacts with water to form sodium hydroxide and liberates the hydrogen gas. This reaction is highly exothermic, that it can even react with cold water. Sometimes this reaction is so much exothermic that it even liberates hydrogen that catches the fire. That shows that this is highly exothermic reaction. After sodium, when we move towards the magnesium, magnesium has a very slight reaction with cold water, but it do reacts with cold water. When it reacts with cold water, it forms a hydroxide, that is magnesium hydroxide. And this magnesium hydroxide, when forms, it acts as a protective layer to stop the further reaction of this metal. Like it acts like a covering on the remaining metal. This hydroxide acts as a barrier or act as a protective layer for the rest of the magnesium. And when it reacts with steam, it forms the magnesium oxide along with the hydrogen gas. So when aluminium reacts with water, it forms aluminium oxide. And this aluminium oxide also acts as a protective layer for the remaining aluminium. But when we talk about the phosphorus and sulfur, they have no reaction with water. Why is that so? Because only those elements reacts with water that can easily ionize. But as you know that ionization energy increases as you move from left to right in a period. So phosphorus and silver has a maximum or greater than all other elements. Their ionization energy is much greater than the ionization energy of sodium and magnesium and aluminium. So they don't react with the water. Then we have a chlorine, and when chlorine reacts with water, it forms HCl along with hypochlorous acid, and sometimes this hypochlorous acid also decomposes to give HCl and oxygen molecules. But sometimes chlorine also reacts with water to form HCl and oxygen molecules. Next we have argon. Argon is a noble gas, and you all know that noble gas are the most stable element of the remaining members. That argon is a noble gas, its octet is complete, it doesn't need to lose or gain or share any electron with any other atom or element. So noble gases doesn't this noble gas doesn't react with neither water nor oxygen nor chlorine. So next we move towards the reaction with oxygen. When sodium reacts with oxygen, it forms a normal oxide, that is sodium oxide. But it also forms the sodium peroxide. Now, what's the difference between normal oxide and peroxide? Whenever you find out the oxidation state in these sodium normal oxide and sodium peroxide, you will come to know that in normal oxide, the oxidation state of sodium is -2. But later on, in sodium peroxide, oxidation state of oxygen changes. Why is that so? Because whenever it normally reacts, its oxidation state is -2. But in peroxide, its oxidation state changes to -1. So with different oxidation state, your products will be different. Then when we move towards the magnesium. Magnesium, when reacts with oxygen, it forms magnesium oxide and it burns in oxygen with an intense white flame to give white solid magnesium oxide. Then you have a silicon. So you have aluminium. Aluminium reacts with oxygen to form aluminium oxide. Then you have silicon. Silicon reacts with oxygen to form silicon dioxide. Phosphorus. When we talk about the phosphorus, when it reacts with oxygen, it may give two possible products. It can be phosphorus trioxide and it can be phosphorus 5 oxide. In phosphorus trioxide, you have a product P4O6, while in phosphorus 5 oxide, you have a P4O10. Again, as in normal oxide and peroxide, there is a difference in oxidation state of phosphorus in both these oxides of phosphorus. Next, we have a sulfur. Whenever sulfur reacts with oxygen, it forms sulfur dioxide. Well, chlorine have many oxides, but it will not react directly with oxygen. It may react indirectly with oxygen molecules and form its oxides, but there is no direct reaction between the chlorine and oxygen. An organ does not react with the oxygen as it is a noble gas. So next we move towards the reaction with chlorine. Whenever an element reacts with chlorine, it forms chloride. First of all, when sodium burns in chlorine, it gives a bright orange flame, and resultantly it produces the sodium chloride, which is of white color. That is actually the salt that you use in your home. Next we have magnesium. Magnesium burns with an intense white flame to give magnesium chloride. Similarly, aluminium reacts with chlorine to give aluminium chloride. And when a chlorine is passed over a silicon powder heated in a tube, it reacts to produce silicon tetrachloride. That is a colorless liquid which vaporizes and can be condensed further along the apparatus. That's how you collect it as your product. Then you have phosphorus. Similarly, it also again has a two different compounds. One with phosphorus 3 chloride and other will be phosphorus 5 chloride. In phosphorus 3 chloride it is PCl3 and in phosphorus pentachloride it is PCl5. Usually phosphorus 3 chloride is a colorless fuming liquid, while phosphorus 5 chloride is an off-white solid. Like there is a difference in their physical state. Like phosphorus 3 chloride is a liquid and phosphorus 5 chloride is, or it can also say phosphorus pentachloride, and it's a white solid. Then we move towards the sulfur. When a stream of chlorine is passed over some heated sulfur, it reacts to form an orange, evil smelling liquid disulfur dichloride. It has odor. And chlorine, how can chlorine react with itself? So it has no reaction, and similarly argon also doesn't react with the chlorine as it is a noble gas. So I think all these reactions are clear now, that how these elements react with chlorine, oxygen, and water molecules, and how they form the hydroxides, oxides, and chlorides. Next, we are going to discuss one by one these hydroxides, oxides, and chlorides in later lectures.